Good morning, everybody. Happy Thursday. Jumping into our last lesson for this week. And in this one, we're going to look at slope a little bit more, and specifically how we can use slope to talk about parallel lines and perpendicular lines. So this is the last video for the week, and then we'll have our weekly assignment. I'm going to put that out today. Tomorrow is grad day, so I won't be putting out new content then. And I'll just throw it out today, but you could, just like last week, right? If you want to do the lesson today and then do the assignment Friday, that's totally fine. You have from now till Sunday at midnight to get that assignment done, and we'll roll through from there. So let's get started here. Let's take our idea of slope and add a little bit more detail to it. Alrighty, page 537, looking at parallel and perpendicular lines. And specifically, we're going to look at the slope of those things. So maybe just to get us started, when I talk about parallel lines, what I'm talking about is two lines that are side by side. They're never going to meet. Normally, we put little arrows on them to kind of signify that they're parallel, but really it's like train tracks, right? Or skis or whatever. Those are parallel lines. Whereas perpendicular lines, okay, means 90 degrees. So I can mark them with a right angle. Two things that come together at 90 degrees. So we'd call them right angled, perpendicular, orthogonal. In physics, you talk about them being the normal. There's lots of ways to refer to perpendicular lines, and that's the other one we're going to talk about. Okay, so very quickly, it asks us to review transformations. So what we're going to do is we're going to explore looking at some parallel lines, and then we're going to explore looking at some perpendicular lines. To be honest, I don't really care about you doing the transformations. I'm going to do the transformations for you, and then we can explore the slopes of these lines. Okay, so we'll skip the little review, and then we'll just do it. Okay, it says, on the grid, show the image of line segment AB after the following transformations. So what that means, the image meaning I'm going to move this, right? I'm going to translate it up, down, side, whatever. And then the new line, we're going to talk about that. So the first one, it says move it 4 units right and 1 unit down. And that's going to be CD. So all I do for point A, I go 4 to the right, 1, 2, 3, 4, 1 down. That's my new point. For B, I would go 4 to the right, 1, 2, 3, 4, 1 down. And there we have it. That would be the line CD. Okay, EF. This one I'm going 3 left and 6 up to form this line segment. So I go back to the original AB. Okay, I'm going to go 3 to the left, 1, 2, 3, and 6 up. 1, 2, 3, 4, 5. I think that's right. And then I have to do the same thing for B. 3 to the left, 1, 2, 3, and up 6. There it is. There you have it. That's the line segment EF. And we'll quickly do that for GH as well. This one said just move it 3 units down. So I take A, move it 3 down. Take B, move it 3 down. Connect that line using a ruler if I had one. And there we go. Those are my 3 line segments. Okay. Well, now it asks us to calculate the slope of each line. Okay. Well, I'm going to start with AB. Okay. I'm going to say M of AB, or slope of AB. And at this point, we could talk about rise or run, or maybe we even use the slope formula. I think it's pretty easy to just count rise over run. From A to B, I go down 3 over 1, 2, 3, 4, 5, 6. Down 3 over 6. So the slope equals rise over run would be -3 over 6. And then I always reduce my fractions. So -1/2. Okay, great. So that's the slope of my original line. And then what I've looked at is I've kind of just moved this line like around. I haven't really spun it. I haven't rotated it at all. I've just moved it up, down, left, right. And let's check the slopes of all of these things. So let's start with the slope of CD. That was the first one we did. Okay, well, from C to D, you go down 3. So negative 3 and over 1, 2, 3, 4, 5, 6. So that's pretty familiar because that's the slope of negative 1/2. Okay, well, let's see what EF is. Let's do that one. Slope of EF equals, from E to F, you go down 3 over 1, 2, 3. Oh my goodness. Reduces to negative 1/2. And now I'm thinking there's got to be some sort of coincidence here. Let's do GH. If I calculate the slope, rise, you fall 3, you go down 3, so negative 3. Run, you go over 6. Oh my goodness. For all of these lines, I got the same exact slopes. Okay? And now we take this and we say, okay, well, can I make a statement about it? Yeah, I can. So these are 4 parallel line segments. They're all, okay, traveling the same direction. They're like train tracks. I didn't really angle them any differently. I just moved them around. So if these are parallel, make a conjecture about the slopes of parallel lines. A conjecture meaning a founded statement. So a statement that you can actually back up, or it's almost like a definition or something like that, right? That's what I mean by conjecture. So I would say parallel lines have, and then you look and you say, okay, well, the first one was negative 1/2 for a slope, and then slope of negative 1/2, and then slope of negative 1/2, and then slope of negative 1/2, and then slope of negative 1/2. Oh, parallel lines have equal slopes. Or in other words, if I have 2 lines that have the same slope, those are parallel lines, which makes sense. They would go up and over, up and over, up and over at the same amount. They're the same steepness, or they're the same slope. So parallel lines have equal slopes. That is huge. That's a massive fact that's going to be really useful for us. Parallel lines, oh, slope is the exact same. I already know it. Okay, let's move on. We're going to look at perpendicular lines, okay, and talk about this. So it says on the grid, plot the point 5, 2. Okay, so I go 5, 2. There it is. That's A. And then it says connect it to the origin. So that'd be O. All right, there we go. And then it says rotate the line through an angle of 90 degrees clockwise about O, or around the origin. So this is where we did transformations in grade 9. You maybe got your trace paper out. You maybe did some different things. Whatever. I'm not going to do that. I'm just going to say, okay, the point would be here. Okay. And we'll call that a prime. Put a little tick on it, or a little apostrophe. Okay. And I know I rotated that thing 90 degrees. So this is a right angle. So what I'm dealing with is from O to A, that's one line, and then compared to O to A prime, well, that would be a 90-degree difference, or these lines are perpendicular. Okay, well, now let's talk about the slopes then. Okay, the slope for, let's go O to A. I rise up 2, and then I run over 5. So my slope would be 2/5. Whereas the other one, M, the slope of O to A prime, well, that one's a lot different. I'm going from here to here. I go down 5, negative 5, and then I run 2. Down 5, negative 5, run 2. Okay. And I'm comparing 2/5 and negative 5/2. So, okay, parallel lines, I had the same slope. Perpendicular, no, those are definitely not the same. But maybe I'm seeing some sort of connection. Then it says multiply them together. Okay, well, 2/5 times negative 5 over 2 equals, okay, multiplying fractions, top times top, bottom times bottom. Top times top, you get negative 10. Bottom times bottom, you get positive 10. And then you say, well, I can actually divide that. It's just negative 1. Okay, so we're kind of thinking, well, why did it make me multiply What number did I get? Was there anything specific? Whatever. All right, let's go to the next one where it says repeat, but we're going to do the point -6, comma 1. Okay, so this is B. -6, comma 1. Here is my point. And I'm going to rotate it 90 degrees, and we're going to do all of that. And we'll see if we can make some statements. So I connect it to O. There's my first line. Do the transformation, which I don't care about you doing. There's B prime. And I know these are perpendicular lines. Okay, well, let's find the slope of these lines. And then we'll multiply it, and we'll maybe make a connection. So from O to B, rise over run. Okay. I'm going to go left to right. I'm going to go from B to O. Down 1 over 1, 2, 3, 4, 5, 6. Down 1 over 6. So my slope would be -1/6. Then from O to B prime, I go up positive 1, 2, 3, 4, 5, 6 over 1. So my slope would be 6 over 1, or I'd probably just write that as 6, right? But leaving it at the fraction, not the worst thing in the world. Okay, then it said to multiply those together, and we'll see what that gets, right? Okay, so -1/6 times 6. Well, if I'm multiplying fractions, I need a denominator, so I'd write it back as a fraction 6 over 1. And top times top, -6, bottom times bottom 6. Hey, I got the same thing. Perpendicular slopes, when I multiplied them, I got -1, which is a little weird. But maybe it's going to allow me to make some sort of statement about it. Okay, it says make a conjecture. I'm not going to do it. We'll kind of talk about it as we go. And now I don't want to do this part at the bottom. So the statement for perpendicular lines is perpendicular slopes multiplied to -1, which is not as concise as parallel slopes. Parallel slopes, they're the same. Boom, done. That's great. But perpendicular slopes, it's this weird multiply thing. The easier way, and we're going to write it on the next page, the easier way, if I compare 2/5 and -5/2, okay, well, 2/5, it was 2 over 5. The perpendicular slope was just the reciprocal of that. The 2 was on top, now it's on the bottom. The 5 was on the bottom, now it's on top. This one was positive, this one was negative. So what we're doing is we're taking the reciprocal fraction, and then I make it negative. Or a nice concise way is the negative reciprocal. Okay, let's summarize that. It's on the next page here. Okay, the slope of any line segment, okay, represents the slope of the line. Yeah, the lines are parallel if they have the same slope. So the first slope equals the second slope. That's how I know if lines are parallel. The other one is the lines are perpendicular if the product of the slope is -1. Okay, so maybe I write it like this or like this, but what's actually easier to look at is the negative reciprocal. And that's this part here. Okay, so it says if I have one slope, if I want a perpendicular one, I flip it. I don't like to use the word flip, but I flip it and I make it negative. Okay. Yeah. Or negative reciprocal. I think it's easier with practice, so let's go through a few. Okay. Consider the line segment AC with a slope of 3/4. Write the slope of a line segment that is parallel. Okay. M parallel. So that's my little notation there. The two lines that are side by side. Slope parallel is 3/4. If I want a slope that's parallel, I write the same slope. It's the easiest question you're ever going to get. If I say, here's a slope, tell me a parallel slope, you tell me the exact same thing. The harder one, okay, is if I ask for slope perpendicular. Okay, oh, that is messy. Let me try that again. Slope perpendicular. It is the negative reciprocal. Okay, so 3/4, the reciprocal of that would be 4/3, where I flip it, and then negative. Okay. What I mean by negative is it needs to be the opposite sign. So since my original was positive, this one needs to be negative. If my original was negative, the new one would be positive. You're taking the opposite sign. Okay, the negative reciprocal. And that's it. Okay. This is something we have to memorize. This is something we have to know. And it's going to be really, really useful for us to have. Okay, let's move on. The slopes of two lines are given. Determine if they are parallel, perpendicular, or neither. First one is 1/4. Second one is 3/12. And you might say, okay, well, they're definitely different, so they're not parallel. But what we have to remember is I need to reduce my fraction. So 1/4, that's all the way reduced. 3/12, well, those are both divisible by 3. That slope is actually 1/4. So my first slope is 1/4. My second slope is 1/4. Since I have equal slopes, they are parallel. Parallel. I never spell this one correctly. There we go. They are parallel. It's as simple as that. If you have equal slopes, they're parallel. Well, if they're parallel, they can't be perpendicular and they can't be neither. So I'm done. Okay. Second one, 5/7 and 14/10. Well, 5/7 is fully reduced. Great. 14/10 would have reduced. Both of those are divisible by 2. And I get 7/5. And we're close. We're thinking perpendicular. We're dancing with the idea of perpendicular. 5/7, and then I have the reciprocal 7/5. But what I need is the negative reciprocal. So this should have been negative 7/5. So this is neither. Okay, right? If I started with M1 equals 5/7, well, then M perpendicular would be negative 7/5. Okay, so we were close, but it wasn't perpendicular. So it's just neither. They're not parallel. They're not perpendicular. They're just something in the middle. They're just any sort of angle. Okay. Well, let's move on. Okay, do a couple of questions. I think I'll do one and then I'll let you do the other. Okay. If P is the point 4,7 and Q is the point 6, -2, find a slope of a line segment. Okay. Parallel to the line segment of PQ. And then B would be perpendicular to the line segment PQ. Well, the first thing I'm going to do is find the slope of PQ. And I'm going to do that using the slope formula. Slope formula you should have written down somewhere. I'll try to give it to you if you're going to use it, but make sure to have it written down before you open a Google form or anything like that. y2 minus y1 over x2 minus x1 equals, well, I better label my points. P, I'll call the first one. I'll call x1, y1. And then Q, we'll call that our second point, x2, y2. And I plug it in. -2 minus 7 over 6 minus 4. So on top, I get -9. On the bottom, I get 6 minus 4, 2. That is my original slope. Okay. And then what I have to do is for A, I'm going to say slope parallel equals, and B, I'm going to say slope perpendicular equals. Okay. So I'm asking you to reference the slope. I asked you to reference slope of PQ, which means you had to actually find that slope. And now we can answer these two questions. So actually, I'll tell you to pause here. It'll take you 2 seconds. Write down the parallel slope and then write down the perpendicular slope.
1 hour later.
And we are back. Parallel slope is the easiest question ever. It is the same exact slope. Don't change anything. The slope of the line I'm referring is -9/2. So a parallel slope would be the same thing. Perpendicular, a little bit harder. This is the negative reciprocal. So instead of 9/2, it's going to be 2/9. And then a negative would actually be positive. So what I'm looking for is the opposite sign. I'm making this negative, so negative is positive. Okay, there you go. Those are my two slopes. So absolutely, that's something I would ask you is, okay, here's, 2 points or 3 points or whatever. Find a slope and then tell me something that would be parallel to it or something that would be perpendicular to it. Okay. All right. Question number 4. Triangle LMN has coordinates -4, 2, -2, 7, and 1, 0. Use slopes to show that the triangle is right angled at L. All right, this is an interesting application. And what it's kind of saying is we can actually use this idea of perpendicular slopes, perpendicular meaning 90 degrees, to prove that something is right angled. So what I'm going to do is I'm going to make a quick sketch, and we'll talk about it a bit more. Okay, point L, -4, 1, 2, 3, 4, comma 2. All right, pretty rough sketch, doesn't have to be perfect, but whatever. Okay, next point, -2, 7. So I have my -2, 1, 2, 3, 4, 5, 6, 7. Right about there. So the first point was L, and then M, and then 1, 0. So I just need my 1 tick. All right, there are my 3 lines. That was M, N. Okay. So I kind of have, 3 lines or 3 slopes that I'd be looking at. And it says use those slopes to show that the triangle is right angled at L. So this gives me a huge gift. It's saying at L, this point right here, I want to know if this is right angled. A harder question would be, hey, here are 3 points. Find the right angle. And then I'd have to find how do these slopes compare, how do these slopes compare, and how do these slopes compare. But really, all I care about is slope ML or LM. How does that compare to the slope of LN? Right? If I can find both of those slopes, okay, if I can find both of those slopes, maybe I'll make them a different color so it's easier to talk about, okay, and then they're perpendicular, then I know it's a right angle. Okay, so I'm going to test that. I don't have rise over run to count. I have to use the slope formula. y2 minus y1 over x2 minus x1, and I'm going to work downwards. For the other one, y2 minus y1 over x2 minus x1. And here's where labeling your points is going to be really, really important, and where for me using different colors helps. So for the first one, I'm using L and M. So L, that's x1, y1. M, that's x2, y2. Those are the 2 points. I'm not even referencing N right now. I'm just using L and M. Okay, so I would say y2 minus y1, 7 minus 2. And x2 minus x1, -2 minus -4. The slope of LM equals 5. 7 minus 2 is 5 over 2. -2 plus 4 would be +2. All right, great. That's my one slope. Now I have to look at the other one to see if they end up being perpendicular. So for the slope of LN, okay, now we're referencing this line. I'm relabeling my points. L, that's still x1, y1, but my x2, y2, that would come from the second point. That would come from N. So just make sure you're looking at the right points. Make sure you're referencing what you're supposed to. Okay, so I'd get 0 minus 2 over 1 minus -4. The slope of LN equals 0 minus 2 is -2, and 1 minus -4, that would be +5. Hey, would you look at that? 5 halves, -2 fifths. Those are negative reciprocals. From 5 halves, I take the reciprocal as 2 fifths, and I make it negative. So since my slopes are negative reciprocals of each other, I know that that's a right angle. So I could even go in and label that on my picture now. I have proved it. Or maybe you could go further and you could say 5 halves times -2 fifths equals -1, right? That was the real definition, as we said, perpendicular slopes multiply to -1. But really, what we're looking for is, are they perpendicular? So, yes, angle L equals 90 degrees. Okay, angle L equals 90 degrees. That's just a little sign that means angle. Okay, great. Last question we're going to look at before I send you for some homework, and I guess before I send you for your weekly assignment and then the weekend. Two lines have slopes of -3/4 and k/5, or something over 5. Find the value of k if the lines are parallel or if they were perpendicular. So here's where we need to know the definitions of parallel and perpendicular so we can work with it. Okay, so the first thing I'm going to do is I'm going to say, instead of -3/4, let's just make the top negative, -3/4. Okay, knowing that that means the same as maybe it's -3/4, or if it was 3/-4, having the negative out front. So that's just a little bit easier. Okay, and then if I look at parallel, what I know is for k/5 to be a parallel line to that, it needs to have the same exact slope. It needs to have a slope of -3/5. Okay, so this thing that I'm trying to figure out has to equal the same thing, or at least it has to reduce to the same thing. And from here, I've got a beautiful equation up, and now I need to solve. Whenever I have a fraction equal a fraction, I can cross multiply, or I can do proportions. Okay, 4 times k, or 4k, equals 5 times -3, -15. And then I would divide. Divide by 4, divide by 4. K is equal to -15/4. That would be a fraction. Maybe we leave it as a fraction. Or maybe I just pull up my calculator and say 15 divided by 4, 3.75. And I know it was negative. There you go. K equals -3.75. All right, perpendicular, a little bit different. K/5, if I wanted that to be perpendicular, I don't want it to equal -3/4. I want it to equal the negative reciprocal, which in this case would be 4/3, positive 4/3, because it started negative and now it's positive. And now I'll go through and I'll do the same exactly. Okay, cross multiply and divide. 3k equals 5 times 4, 20. Divide by 3. Divide by 3. K is equal to 20 divided by 3, 6.6 repeating. And I'll just do that with the repeater sign. So maybe you leave it as a fraction, maybe you leave it as a decimal. If I was ever asking a real question, I would specify. And that's it. Okay, parallel and perpendicular slopes. Okay, so maybe I'll write it down so we can remember. Okay, parallel, slopes are equal. Parallel slopes are equal. That's huge. That one's really important. And then perpendicular slopes are negative reciprocals, are the negative reciprocal. Reciprocal. Oh, I spelled that wrong already. Reciprocal. Maybe it's spelled right, maybe it's not. Okay, so that's going to pop up later in the unit, and it's going to be important to know. It's just kind of a skill to have in our back pocket of knowing those parallel lines, those train tracks, those are equal slopes, whereas those perpendicular lines, those would be the negative reciprocal of each other. All right, there's your homework. 3, 4, 5, 7, 10A, 11A. First 2, 3 questions are really quick, and then a couple more challenging ones. And then your weekly assignment, and you are on to the weekend. And there you have it, guys. Parallel and perpendicular slope. So you got a little bit of homework to do, and then you have your weekly assignment that you could get done today, or you could wait till maybe Friday to do it, or over the weekend, and it's due at Sunday. Other than that, make sure you're asking lots of questions. Send them into the Google form, set up a one-on-one appointment, all of that. Smash the like button, hit subscribe, tune in again next week for some more videos. Bye.